It is 3 a.m. Your payment service just started throwing 500 errors. A standard runbook script isn't going to save you, because this isn't a known issue. You have to wake up, groggy, open your laptop, pull logs, query Prometheus, and manually trace the dependency tree until you find the bad commit. By the time you fix it, you've lost thousands of dollars in revenue in your entire night of sleep. But what if your infrastructure could reason about its own failures? Traditional automation is dumb. It says, if X happens, run script Y. But production environments are chaotic. An AI SRE is different. It's an autonomous agent sitting inside the incident loop. It watches the cluster state continuously, forms a diagnosis from raw evidence, and proposes a specific change. We are building a graduated trust model. The agent executes the fix in a credential-injected sandbox, and for high-risk changes, it pauses and sends an interactive Slack message requiring a human to click approve before applying the kubectl command. Let's look at the code. Everything I'm showing you is open source, and the link to the GitHub repo is down in the description. First, we set up FastAPI to catch the webhook from Kubernetes. We extract the exact pod name, namespace, and the exact timestamp the pod died. Now for the brain. We are passing this context into our specialized triage agent. I am equipping this agent with 3 specific tools: a metrics tool to read Prometheus, a log tool to pull from Loki, and a kube tool which allows it to run read-only kubectl describe commands. Enough theory. Let's trigger a live outage. I am running a load test script that intentionally causes a massive memory leak in our front-end service. The pod's memory limit is set to 256 megabytes. Watch the left terminal. The pod just died. The webhook fires. The AI agent wakes up. It's querying the logs. It sees the out-of-memory exception. It realizes the limits. Memory is too low for the current load. Exactly 12 seconds later, I get this Slack message. The AI explains the root cause, cites the exact log lines, and proposes a kubectl patch to increase the memory limit to 512 megabytes. Because this modifies infrastructure, it asks for permission. I click approve. The patch is applied. The new pod spins up cleanly. The incident is resolved, and a complete post-mortem markdown file is automatically pushed to our documentation repository. Total downtime: 28 seconds. This is a massive paradigm shift. We are moving from observability, which just tells a human what is broken, to actionability, where the system fixes itself. But you have to respect the blast radius. If you deploy this in your own clusters, ensure you scope your service accounts strictly. Read-only access by default, and isolate remediation permissions strictly to the namespaces the agent is responsible for. If you want to run this in your own environment, I've packaged the complete Python backend, the Kubernetes manifests, and the Slack bot templates into a repository. The link is right below the like button. Fork it, break it, and let me know what cloud platform we should let this agent take over next. Keep building, and I'll see you in the next one.